Hey everybody, welcome back to Unit 7.4. Today we are talking about another method for factoring. This is called difference of squares. Okay, so difference of squares happens when there are two terms in the expression and every single component of the expression is a perfect square. Okay, the nice thing about difference of squares is we're going to follow a formula. Okay, so the expression a squared minus b squared will factor as a plus b, a minus b. Okay, and the expressions in your final answer are going to be the square roots of the original terms. Okay, now in addition to everything being a perfect square, the problem also has to be subtraction. Okay, as it says in the name, it has to be difference of squares. So if you have an addition problem, it is most likely not this method. Okay, any variable can be a perfect square as long as it has an even exponent. In order to find the square root of variables with even exponents, we just divide the exponent by 2. Okay, so let's take a look at what that means. All right, so here I have some terms, and we just want to find the square root of each. So the square root of x to the 6th would just be dividing my exponent by 2. It would be x cubed. Okay, the square root of 16m to the 18th, okay, we could do it separately, and the square root of 16 is 4, and then my variable we would divide by 2. Okay, so again, square root of a variable, you are just dividing by 2. So the exponent itself does not have to be a number that's a perfect square. It just has to be even so that it's divisible. All right, and this last one. So you take the square root of the coefficient, so that's 7, and then the variable we just divide by 2. All right, so now that we're able to find the square root of each term, it would then just be a matter of putting it into our formula of a plus b, a minus b. All right, so let's get to these. So two terms, I have subtraction. I'm going to square root each term, and you don't have to worry about the minus. So the square root here is x and 7. So we're going to take those and plug them into our formula. So x plus 7, x minus 7. The order of the parentheses doesn't matter. Okay, and again, you could FOIL this and get back to your original question of x squared minus 49, and that's how you know you did the problem correctly. Okay, I'm hoping that you found that very, very easy. This is a simple method. Just when it's all mixed together with every type of factoring problem that we've seen, sometimes it's hard to identify. Okay, so again, square root everything. So this is 25x squared, and this is 6. So now we're going to put it into, I'm sorry, not 25, just 5. And we're going to put it into our formula now. So a plus b, a minus b. All right, so the coefficient and the variable, you want everything to be a perfect square. Okay, so make sure you're always checking for GCF as well. We haven't encountered that yet, but you never know. All right, so I have 2x squared and 9, my square roots. So 2x squared plus 9, 2x squared minus 9. All right, keep going here. So now both of these terms have a coefficient and a variable. Okay, so just make sure that you're checking all parts of the problem. Okay, that is your final answer. All right, so this problem happens to have a GCF. So I'm going to take an x out before I start. Okay, and that is actually much better for me because x cubed and x to the first power, those were not even exponents, so they would not have been considered a perfect square. All right, so we know GCF always gets dropped to the bottom. And now I'm going to square root these. So this is 9x, and this is 2. Okay, so in addition to my GCF, I have my two factors. All right, okay, one last example that I want to do for you, just over to the side here. Okay, I want x to the 12 minus 81. Okay, so this is all a perfect square, even exponents, and a perfect square number. Okay, so I get x to the 6th and 9. So x to the 6th plus 9, x to the 6th minus 9. Okay, now I want you to take a look at this answer that we have, and do you notice anything? Okay, I'm hoping you see that this is another difference of square problem. I have another problem still. I have an even exponent and I have a perfect square number. I need to continue to factor. So I'm going to drop this down to the bottom, kind of the same way that I do with my GCF, because it's still part of the problem, but there's more work that I need to do. And I can square root each of these terms, x cubed, and this is now a 3. And now I can do my formula on those terms. Now this only works when every part, of that parenthesis is a perfect square again. Okay, and you don't want to keep dividing like the original problem. So we took the square root once and we got x to the 6th and 9. You don't want to take the square root again until you've put it into the formula. So it's always square root formula, okay? And that's only if it works the next time around. We didn't do it on the first parenthesis because the first parenthesis was a plus. It wasn't a difference of squares. We could only do it on the parenthesis that had the minus in it. Okay, so that's kind of like a special case for difference of squares. We can definitely talk more about that when we do some practice when we are together. Okay, but that is everything for difference of squares. It's a very short, quick hit little method. Okay, so just make sure that your notes are complete. If you have any questions, just write those down. And I thank you guys so much for watching. I will see you next time.